Let's discuss this problem from statics. So a mass of 2 kg is kept on the floor, which is a rough surface, and a friction coefficient, the limiting friction coefficient is given. So let's first draw a free body diagram. You have a block here which is lying on the ground. So the first force is the mg, which is mass is 2, and g is we are asked to take as 20. So 20 Newton is the weight, and here you have the normal reaction, which is from the ground, and let's say a 3 Newton is applied to the block in the horizontal. So I'm applying a 3 Newton here, and obviously the 3 Newton tries to slide the block towards the right, and therefore the relative speed at the interface between the block and the ground, or the surface on which the block is kept, the relative speed is towards right, and therefore the friction opposes that, and that is the value of friction. Now, the common mistake which people do in this problem is that they start calculating the friction based on the friction coefficient that is given. Now, remember that the friction value which you calculate from the limiting friction is the maximum friction. So let's first calculate the friction coefficient, but remember that this is not F, this is the maximum friction. So mu into N is the maximum friction. Okay, this is the formula, but for that we need to know N. Now here is a body. Okay, so let's first assume that we have equilibrium. Okay, this is the common strategy in any problem where you have friction. First assume that it's in equilibrium, and then we will check our assumption by the fact that F is less than F max, then it will be a static equilibrium. F is greater than F max, then it will be the surface doesn't have the capacity to be in static equilibrium. So first, summation F is equal to 0. So we are assuming that it's in static equilibrium, and then we'll check the assumption based on the friction value. Assumption that static equilibrium. This is a common strategy in any equilibrium problem. So sigma F at 0. So for that, towards the right I have 3 minus F is equal to 0. So F is 3 Newton. So this is the friction that is required to keep the block in equilibrium. And now in the other direction, N is upwards minus mg, which is 20, and there is no other force. N is 20. Okay, so these are the values which I got. Now in the y direction there will be always equilibrium. The block doesn't move vertically, so this is always full. In the y direction there will be always equilibrium, but in the x direction, assuming that we have static equilibrium, the F is 3. So in order to provide equilibrium, the friction force required is, the actual friction force required is 3 Newtons. The maximum static friction, or which is also called as the limiting friction, is mu into N, and mu is 0.2, N is 20, so that is 4 Newtons, right? So the maximum that the friction can go between the surface and the block is 4 Newtons, beyond which there will be a slipping or sliding. Okay, so in this case the F actual is less than F max, because 3 is less than 4 comparing the values. That means our assumption is correct. And the block is in static equilibrium. So when the block is in static equilibrium, sigma Fx is 0, and hence ma. So basically there is no acceleration. I mean, it is in equilibrium, there is no acceleration. So that is the answer for this problem. The answer is B, which is 0. Remember that many people would just take the value of friction as 4 and then compute the acceleration. They may get 1 by 2, which is 0.5, right? So that would be wrong. I mean, you should always, in these kind of friction problems, you should always make an assumption. It's a static equilibrium, and then solve. Check the value of actual friction that is required to support equilibrium. compared with the limiting friction. Now, in order to maintain equilibrium, if the friction required is less than F max, as the case here, then the equilibrium prevails. But if the actual friction required to maintain equilibrium is greater than the F max, let's say if I applied 5 Newton, then F comes out to be 5 Newton for maintaining equilibrium here, then 5 is greater than 4, which is F max. In that case, the block will slip. It cannot hold in equilibrium. That is the whole idea about friction. So the answer is B. Thank you.